Alrighty, so let's really understand how side, 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 alright, implies congruency between two or more triangles, right? And again, this is just implying that this side and this side of the two triangles are congruent. The second side are also congruent, and then the third side is also congruent. Alright? And what this tells us is that these two triangles, again, I already said it, are congruent. Alright? But what is it? What's actually happening here underneath the surface? Alright? So I'm going to write this real quick. SSS tells us it implies congruency. It implies congruency. All right. And what is congruency when we're talking specifically about shapes? Well, it means that two or more shapes are the same size and, of course, the same shape. All right. But what does this tell us? What does it mean for something to have the same size and the same shape? Well, that just means that all the angles in those triangles are equal to each other. So this angle is equal to this one. That angle is the same measure as that one, and this angle is the same measure as this one. Right? So it tells us all angles are equal in measure, and all their side lengths are equal in measure. So I'm just going to put plus sides. All right? But let's actually understand how and why side, side, side works. Okay? How does it show that two triangles are congruent? All right? So I have this second sheet here, and it's the same exact triangles. All right, but I don't have this one finished to really show you what's going on here. All right, so again, we're doing side, 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 right? So that means this side is congruent to that side, and then we have this side that's going to be congruent to another side over here on this triangle, and then we have that third side that's also going to be congruent to one of these sides on the triangle. Okay, but how can we prove this? How can we show that side, side, side implies congruency? Well, if we break it down, and it's super easy to break this down. Well, let's first look at this length here. Okay, we know that this length and that length should be the same. All right, so let's go ahead and I'm going to grab my compass here. I'm going to try my best to measure this. So that looks about right there. Looks about the same distance, or the right distance. All right, so that means this line should be the same distance. You can see it is. It's the same exact distance. So this side and that side are congruent, okay? So where do we know? How do we know that the other sides are going to be placed exactly where they are here? How do we know it's going to be at that kind of certain angle there, and at this certain angle here, and that certain angle? How do we know that it's going to lay perfectly like this? Well, one way to think about it is well, let's look at the side measures. Well, this from this point, and again, obviously this is the end of the first segment, right? So up here, right? From this point, or that vertex, to this vertex, it is that exact distance here. Let me see if I can get a little bit more perfect. It is that distance, all right? So if my triangles are all the same side lengths, then I should be able to come over here and just translate it, right? And I should be able to lay this right on top of that point and conclude that the end of that point should lay somewhere on this arc here, okay? Somewhere there, okay? Again, all I'm doing here is, well, if this is the measure of this side, and on this other triangle over here, it's going to be the same measure, then that means it just needs to land, and it needs to land somewhere, again, on this arc here. It needs to land somewhere here, all right? And the same thing applies to this side. Well, how far is this point to that point? Well, if we take our trusty old compass here, and let me see if I can get a better view for you guys. Looks like it's that far. All right. So if I come and put it over here on the side it's supposed to be on, that means that other endpoint is going to lay somewhere on this arc. And you can kind of see what we kind of did there. We know exactly where that third point is going to end, or it's going to lay. It's going to be at the intersection of those two arcs, right? And I'll show you how that works in a sec. So that means they're going to intersect there. So that means this line, or this point, will connect to this point, that vertice. And this point and this point will connect. Okay? And all of a sudden, we now have a triangle. Okay? But how do we prove that they're congruent side, 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 via side, side, side? So this side should be congruent to that side. Well, we can check that. We can proof check that. So let's see how far that is. Looks like it's that far. So that means that should be the same distance over here. And what do you see? What do you have? They're the same distance. So that means that side and this side are congruent. What about this side here? Well, if we measure it, should be that far, or that distance there. So if I come over here, it should be the same distance. And look there, we have the same distance. So that means this line, or that line segment, is congruent to this line segment. And we have now shown that side, side, side works, and it proves, it implies that two triangles are indeed congruent.